You've probably used ChatGPT or seen what Google's AI can do. It feels a bit like magic, right? But have you ever stopped to wonder how it actually understands what we're saying? Well, today we're going to pull back the curtain on the secret sauce, the one powerful mechanism that really sparked this whole AI revolution. It's called self-attention. It all starts with a question that seems simple but is actually incredibly difficult for a computer. For us, understanding a sentence is just second nature. But for a machine, figuring out the relationships between words and what's important, well, that's a massive challenge. Take a look at this. It perfectly captures the problem. We've got the word bank in two sentences, but it means two completely different things. In one, it's a riverbank. In the other, it's a building with money. The only thing that changed was the context, the words around it. And that is the exact puzzle that AI had to solve. So this is what we're up against. This core ambiguity, let's just call it the bank problem, is where our whole journey kicks off. Here's the thing you gotta remember. A neural network doesn't see words like bank. It sees a list of numbers. And without any extra help, that list of numbers is identical in both sentences. So for an AI to truly get it, we need to build some kind of mechanism that lets it look at its neighbors, words like swam and river, for clues. So how do we actually do that? Well, the solution is all about getting words to, well, pay attention to their neighbors. Let's see how this works. First things first, we have to turn language into numbers that a computer can actually work with. We do this using something called word vectors. You can think of a word vector as a coordinate on a giant map of meaning. So words like king and queen would be really close together on this map. The problem is that an ambiguous word like bank starts out kind of close to both money and river. And that sets up our main goal. Our mission is to create a process that can dynamically tug or pull the vector for bank so that, in this specific sentence, it moves closer to the meaning of river and way further from the meaning of money. That's the core idea we're chasing here. And believe it or not, this is done with a surprisingly elegant three-step mechanism. Let's break down exactly how it works. Okay, so first, every single word looks at every other word and scores how similar they are. Second, we take those raw scores and clean them up into useful weights. And third, we use those weights to blend all the original words together, creating a brand new, context-rich version of each one. Let's dig into step one. The tool we use for scoring is a math thing called the dot product. But don't worry, you do not need to be a math whiz for this. The only thing you need to know is this. If two word vectors are pointing in a similar direction on that big map of meaning, their dot product is going to be a large number. It's basically just a score of how much they agree. Simple as that. And here you can see this process in action. The AI calculates a score for every possible pair of words. See the dark circles? In our sentence, words like swam, river, and bank would all get high scores with each other. They agree, which signals a really strong contextual link. This brings us to the final and honestly the most beautiful part of this process. The word vector is literally tugged and pulled into a new position, one where its meaning is enhanced by its neighbors. Those high scores we just talked about become high weights, and they're used to create a new, context-aware vector for bank. It's brilliant. Okay, so that's the core concept. But to make this whole thing truly intelligent, and more importantly, trainable, we need to introduce three new ideas: query, key, and value. Because if you think about it, everything we've described up to this point is just a fixed calculation. The dot product scores will always be the same. So, where does the learning come in? Where's the AI part of all this? The answer comes from a fantastic analogy. Think of it like a database search. For each word, we create three different versions of it. The query is the word asking, hey everyone, who here is relevant to my meaning? The key is every other word answering back, this is who I am, check if we're a match. And the value is every other word offering up its pure meaning to be mixed in. So here it is. This is the real secret sauce. We don't just use the same word vector for all three roles. No, we pass the original vector through three separate, trainable neural network layers. This creates a unique query, a unique key, and a unique value. This is where the learning happens. Those layers have weights that get adjusted during training, allowing the model to learn exactly which types of queries should pay attention to which types of keys. But we can take this even one step further. Language is incredibly complex, right? So let's get to the final piece of the puzzle and see how this all scales up into something even more powerful by doing attention in parallel. Which leads to a really good question. Can a single query key value system really capture everything? Can it track grammar, subject-object relationships, and semantic meaning all at the same time? Probably not. If you ask one mechanism to do everything at once, you risk it becoming a jack of all trades, master of none. It just gets overtaxed trying to learn too many different kinds of relationships. And the solution to this is an absolutely ingenious idea called multi-head attention. Instead of one generalist, we create a team of specialists. We just run multiple attention mechanisms, or heads, at the same time. Each head gets its own set of query, key, and value weights. So one can become a specialist in grammar, another can focus on pronoun references, and another on thematic links. They all work together to build a much richer understanding of the sentence. So that's the mechanics of self-attention. I know, it's a bit involved, but the core idea is pretty simple, and it has had a world-changing impact. Let's put this on a timeline. This whole concept was introduced in a huge 2017 paper, perfectly named Attention is All You Need. Just 1 year later, Google's BERT model used it to shatter all the records in language understanding. Then OpenAI's GPT series scaled it way up, leading directly to the powerful AI we all use today. It all comes back to this one idea. And what's truly incredible is that this isn't just about text anymore. Researchers are now applying the exact same multi-head attention idea to computer vision by treating an image as a sentence of little patches, and even to complex scientific fields like drug discovery. It's become a fundamental building block for all of AI. Which brings us to a final, powerful question to leave you with. Self-attention gave machines the ability to understand context. It's the reason AI can tell the difference between a riverbank and a money bank. So as we keep building on this, what are the limits? If an AI can truly grasp context, what can't it eventually understand?